Hi, in this video, we will be discussing how line of best fit is plotted. For that, we have this data point about which I have discussed in previous lecture in detail that what this data set is about. Okay, to draw a best line of fit, let's say I have this line. This is a line on this data point. What Python will do, it will calculate the distance of each data point to this line. Like it will make the right angle. Like this is the data point, right? So it will have this line, and Python will calculate the distance. And about this data point, we will have this distance. These are the straight distance line. About this data point, we have this distance. And for every point, we will calculate the distance. And if the distance is less, then we will say, okay, this is the best line of fit. Now, one line is this, and the other line is, let's say, other line is this. Okay. Now Python will calculate distance of each data point to our new line, and what it will be, it will like from this data point, this distance, from this data point, this distance. I hope you are getting a good idea. This data point, this distance, this data point, this distance, and so on. It will calculate the distances from each of the data point. So, and it will calculate the distance for all the possible lines. Like there are many possible lines. One possible line may be this, and other may be this, and other may be this. There are number of lines. So the line at which the distance is least, the distance of points, data points is least, that will be line of best fit. I will remove the unnecessary lines here, which were these, and on the present two lines, I have explained how we calculated the distances. So what we get from this diagram for this position, for this particular point. Okay, for this point, let me open up my, okay. Now, which line do you think is the best fit? Because this line, I am just drawing the line again. This line, there is more distance. Not that it is like larger distances. This large distance, this large distance, this large distance, and each data point will have so much distance. So I think that this line is not the best fit as there is more distances. Other than that, this line, look at this line, the distance of each data point is less. Like this is less distance than the upper line. They were having more distances. And some of the points, like this point, very small distance. This point, very small distance. This point, very small distance. And this point, also small distance. So I think that this line is more good fit for our model instead of this line. But Python will not confuse this way, like I'm saying, I think. Python will not think. Python will calculate the exact distances and it will select the line with the least distance. Okay, for now, I am removing all the annotations I have drawn here, and I will show you how Python have drawn the best fit line. Okay, on the same dataset, here is the best fit line that is drawn by Python. Okay, I hope this is making good sense and Python have selected this line. If you calculate distance of each data point to the line, this, 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 and these all distances, it will give the minimum value than any other line on this graph. any other line, like if you draw this line, if you draw this line, the line must be straight. Any other line will have more distance than this line. So as this green line is having the least distance, so this is the best line of fit that is drawn by our model. Now, one thing to iterate here is that the how the distances are calculated. Distances are calculated with the formula that is shown previously, and that's the basically formula to calculate the distance between one point to the other point. So these are the distances, these are the straight lines I have drawn. Okay, what is happening here? I will calculate some of the annotations. Okay, now I will show you the distance. This is how the distance is calculated, right? These are the straight lines. Now the distance is calculated with the formula that I shown you, and that formula is for calculating the distance between 2 points in a 2D plane. So one point is this and the other point is this. So what we suppose that this will have positive distance and this will have negative distance, right? This distance and this distance. There will be a change of sign, right? Because one is above the point and the other is below the point. So one distance will be like negative and the other distance may come positive by that formula to like after that we will sum all the distances, right? This distance, this distance, this distance, and all the distances are added so that we have a final value. In this case, when we say, like, let's say one distance 5 plus other distances, let's say -4. So that's not right because 5 plus -4 will give me 1. But I don't want such confusion of negative values. So I have to do something with these. What I will do, I will take squares. I will delete all the annotations for first. Okay, I will take squares. What I mean here, mm, let's say here I was having 5 plus, and here we have -4, and that gave me 1. But originally, what will happen? 5 square, 25 plus -4 squared, and it will give me 16. It will not give me -16 because negative multiplied by negative will give me positive. So that's why we take square of each of the distance, and 25 plus 16, it will give me 39. It will give me 41, sorry. Okay, so this is how the distances are calculated. We will take square of each of the distance and we will add all the distances at the end, like this distance square, this distance square, this distance square, and all the squared distances, and after that we will add those, and the distance of this line will be minimum. You can draw any other line and it will have more distance. If you have enough time, you have 3 to 4 hours, you can check. You can check 2 to 3 lines and see the distance for each of the line at the end. Take squares and add all and see which line have the least error, and that will be the best fit line.